classwork on histograms starts with a histogram that's given to us where we're asked to find certain proportions. I think the best thing to do for this is to try and figure out what the individual bars are as proportions before I start answering these questions. So this first part I'm going to say is about 0.01. This second bar is 0.04. This bar is 0.13, 0.21, 0.22, 0.16, 0.10, 0.08, and 0.04. I'm eyeballing these mostly. I would say that they are somewhat clear on the ones that you're asked for homework, but it's possible that I'm off by 0.01 on one of these. If I get an answer wrong, I might want to go back and revisit it and just kind of say, wait, did I call that 0.16 when it should have been 0.17? But in general, I should be able to see about where these bars are meaning to go along the scale. If I'm now being asked what proportion of the measurements are less than 20, here's where 20 is. Less than 20 includes all the bars to the left. That's only this one bar at 0.01. I'm then asked what proportion of the measurements are between 60 and 70. Here's 60. Here's a line in the middle of 60 and 80, so I assume that's 70. That means that this one bar is between 60 and 70, and I labeled that one bar 0.16. When I'm asked what proportion of measurements are greater than 80, in this case, here's 80. Greater than means to the right, so it includes both this bar that's 80 to 90 and this bar that's 90 to 100. So that first bar had a proportion of 0.08. The second bar had a proportion of 0.04. When I combine them, I get an overall proportion of 0.12. For part D, I asked what proportion are between 50 and 80. So 50 and 80 would include all three of these bars. The first bar is 0.22. The second bar is 0.16, and the third bar is 0.10. If I add all three of these together, 0.22 plus 0.16 gives me 0.38, plus 0.10 gives me 0.48. Question E asks me, what's the general shape of this distribution? In general, it's got a highest point in the middle. As I go down either side, it gets lower. This, in general, is a symmetric distribution. Next task I'm asked to complete is use this information to find class width and list class boundaries. I'm asked to do 6 classes for 27 measurements, which have a minimum value of 0 and a maximum value of 11. When you're asked to find class width, the class width formula is width equals max minus min divided by number of classes. In this case, we were told our maximum value is 11, our minimum value is 0, and the number of classes we want to create is 6. This gives me 11 divided by 6. If I put that into my calculator, 11 divided by 6, it gives me 1.83. In general, we'd rather round to the nearest whole number, so instead of calling this 1.83, I'm going to call it 2. I would replace my class width with 2. I'd then go to set class boundaries. When I'm setting class boundaries, they're really counting both a lower class limit and an upper class limit as separate boundaries. So what I want to do is start at my minimum value, 0, write that as my first class boundary. From my first class boundary, I want to add the class width, so 0 plus 2 gets me to 2. I then want to keep adding the class width until I get to something that's beyond the maximum. So if I add 2 to 2, I get 4, 6, 8, 10. I can't stop at 10 because I still have a measurement, 11, which is beyond that class boundary. So again, I go the class width of 2, and I wind up at 12. Since 12 is larger than or equal to my largest data point, I can stop there and say these are the class boundaries. Really, if I wanted to write them as class limits, it would be 0 to 2, 3 to 4, 5 to 6, and so on. But when it asks for class boundaries, it's just asking for these endpoints.